Have UFOs been seen in Los Angeles, UK, or Washington, D.C.? Is Area 51 a secret facility for aliens? Is there life outside Earth? Are aliens real? Questions like these have plagued humans for decades, but we are now closer than ever to an accurate answer to the mysteries of the universe, all thanks to the new James Webb Telescope. The ingredients for life on Earth evolved and emerged from the tangle of molecules, stars, galaxies, black holes, and planets that populate the universe. Are the conditions that encourage this flourishing, noisy biosphere shared by the galaxy's millions, if not billions of rocky planets? How will the Webb Telescope answer this question? Examining exoplanets. Discovering an alien civilization would radically alter our understanding of the universe and how the human race and Earth fit into an infinitely vast and intricate cosmos. In 1989, the new telescope was not conceived to look for signs of extraterrestrial life, but in the time that it took to build this $10 million project, a new field of astronomy had emerged that focused on planets outside our solar system, called exoplanets. Only a few of the thousands of exoplanets we've discovered in our galaxy resemble planets in our own solar system. The rest are undeniably alien, and data from the new telescope is expected to help us better understand them. With Webb now serving as the next generation of astronomy, it can draw the spotlight to the possibility of inhabited worlds outside our solar system. NASA's flagship telescope will observe hundreds, if not thousands, of exoplanets in quest of answers to the question of alien life. It will gaze upon terrible lava worlds with molten surfaces that revolve around their stars in minutes. It will investigate worlds that have miraculously survived their stars' horrific deaths and currently orbit their celestial corpses. It will peer into the atmospheres of gas giant planets, scour the dusty disks that cling to infant stars for newborn worlds, and stare at a handful of small rocky worlds that could be similar to Earth. How does the telescope work? Along with exoplanets, scientists will also use Webb's spectroscopic capabilities to explore interstellar interlopers that visit our solar system in both the mid-infrared and near-infrared bands. According to a NASA film on the flagship telescope's optical system, its mirror segments were coated with a thin layer of pure gold, less than 100 atoms thick, to best reflect infrared light. The Webb telescope will primarily see the universe in infrared light through its massive honeycomb-like golden eye. The observatory's remarkable sensitivity will allow the telescope to spot the faint, remote signatures of the universe's first stars and galaxies. JWST can directly image some of the dim, faraway planets in orbit, including those that are still forming, by blocking the light of planets' parent stars with an instrument called a coronagraph. The telescope can look through alien atmospheres to see what the gassy shrouds are made of and how they've changed through time. It can also read molecular markers in planets' day-side glow. How did these planets get to where they are now? What happened to them along the way? And what situation would lead to biosignatures or life? These are the questions that NASA's Nicole Colon will ask, looking for alien life as the deputy project scientist for Webb's exoplanet mission, detecting alien life in the form of plants. The first direct images of extraterrestrial worlds in the orbit of distant stars is another capability that astronomers expect from Webb. The telescope might even detect signs of life if all the conditions are favorable. Yes, this means actual photographs of aliens. Isn't that crazy? It's an exciting prospect, which is why discovering bio and techno-signatures on other worlds has been a popular topic for years. A new method for detecting plant life has been proposed as a result of a recent discovery of phosphine in Venus's atmosphere, which has led some scientists to speculate that it was generated by a microbial life form here in our solar system. Because plants generate energy through photosynthesis, which can be seen in infrared wavelengths when visible light is absorbed by chlorophyll, an extraterrestrial world covered in greenery register in Webb's array as a distinct red edge, detecting alien life through the atmosphere. Scientists on Earth can gather enough information to suggest the presence of biological life in a distant alien world from only a single pixel image by using data from the Webb telescope. Detecting more complex life, possibly intelligent life similar to ours, may be more tricky. But the simplest way to figure out how we discover alien life is to look at how humans appear on Earth from the point of view of space. Our civilization generates vast amounts of waste heat from countless households and never-ending industrial production. Add in the distinctive glow of artificial darkness throughout the night, and our planet appears to be buzzing with activity from low Earth orbit. However, as you get further away, these life indicators grow fainter, so anyone hunting for humans may have to scan for chemicals. Therefore, the best approach to detect a society like ours from deep space is to hunt for signs of the chemicals we produce and release into the atmosphere, especially molecules that would not be produced on a planet like ours without human activity. Ironically, the damage many of these compounds cause to our biosphere could be how alien civilizations on other worlds spot us with their telescope, but it also means we can do the same to them if we had a powerful enough telescope. And that's where the James Webb Telescope comes in to save the day. The telescope will begin drinking in starlight and exploring faraway worlds about 6 months after arriving in orbit, and planets will appear in silhouette as they pass between their stars and the telescope, highlighted by the starlight shining through from behind. Webb will then read the characteristics of the gases the light passed through. A group of experts looked into how we may look for man-made chemical compounds, specifically chlorofluorocarbons or CFCs, produced by industries that utilize cleaning chemicals and refrigerants. This is the same chemical that notoriously ripped a massive hole in our planet's ozone layer in the 1980s. Looking for these potent greenhouse agents with long atmospheric residence times elsewhere in the Milky Way would almost certainly reveal the existence of a thriving alien civilization, perhaps grappling with the same industrial excesses that are threatening human life on Earth. Humans may be forced to speculate about the alien civilizations depending on the distance between Webb and an alien world with CFCs or another dangerous chemical substance in its atmosphere. After all, our civilization's current set of social and environmental conflicts may not stand the test of time. We would be looking at a world that has evolved beyond pollution-producing energy sources if we find an alien world 1,000 light-years away, or an alien world that may have failed to remedy its excesses or may have already perished due to nuclear destruction. Because light has a finite speed, the only way we'd know for sure that an alien civilization exists as we see it is if it's close enough to reduce the lag time in images caused by the speed of light. Let's hope that alien civilizations set mostly good precedents and that we can learn from them. Who knew that alien life could be the answer to climate change? A long search for life. The scientific community and the public are very excited about the possibilities that the Webb Telescope will open for us. It's like a new door to the universe, but we must take this mission with a grain of salt. While the JWST will undoubtedly revolutionize our understanding of the worlds that make up our galaxy, scientists are unlikely to find signs of alien life unless they're incredibly lucky. That kind of observation is right on the edge of the telescope's capabilities, and it would take a very long time to accomplish. There are too many uncertainties and unanswered questions right now, but the JWST will help build the groundwork for future attempts to discover biospheres. In fact, scientists are already working on the Webb Telescope's successor, a giant space telescope to discover biosignatures on alien worlds similar to Earth. A few decades ago, humans weren't even thinking about exoplanets, and today we are launching a telescope to explore them. It will be a long road, but the James Webb Space Telescope has made the impossible possible. What are your theories about alien life? How and when do you think we will find them? Will we find them at all, or is this a pointless search? Let us know in the comments section below. And while you're there, don't forget to hit the like button and subscribe to our channel.